Hi guys, Professor Burns here, and we have reached our last new lesson for our course this semester, where we are looking at comparing the means for two different populations or two different groups. And we've been doing this in the last couple of chapters where we talked about comparing proportions with two different groups. Now we're going to look at comparing numerical data, looking at means and how those compare. So we're going to focus on conducting a hypothesis test or creating a confidence interval with two different population means. One thing that's a little bit new in this section that we just kind of want to get our feet wet with, we won't do a whole lot with this, but we want to talk about it a little bit in case you see it down the road in another stats course, is whether or not the samples that we are working with, if they are coming from a group that is independent, which is normally what we work with, and that's our assumption, is that we're dealing with two different independent groups, like men versus women, for example, or something like that. Or if they come from paired samples or dependent samples. And we'll look at some examples of the difference here. If they are paired or dependent samples, then each observation, one group, is paired or related to each observation in the other group, or with one particular observation in the other group in some way. So this can be people that live in the same household. This could be people that are related physically, people that are married, but it could also be the same group of people, just measured in two different ways, like a before and after comparison, or where we ask them two different measurements, but it's the same group of people, something like that. So let's do a couple of examples. The first example, it says the people chosen in a random sample are asked how many minutes per day they spend reading, and then we ask them how many minutes per day they spend exercising. And it's all in the same day. Researchers want to know how different the mean amounts of times were for each activity. So is this dependent or independent? Well, the thing to keep in mind here is that it is the same group of people. We're just asking them two different measurements. How many minutes a day do you read versus how many minutes a day do you exercise? So for that reason, this would be a dependent or paired samples. And if you want to make a note, it's because it's the same group of people. We've just asked them two different questions, basically. The next question says, a sample of men and women each had their hearing tested. Researchers want to know whether typically men and women differed in their hearing ability. So assuming these are random men and women and they're not, married couples or siblings or anything like that, then I would say this is an independent sample because we're dealing with two totally different groups and asking them the same question, or measuring their hearing ability in whatever test we're using. So assuming it's a random group of men and another random group of women, then I would say those are independent samples that we're looking at. So the next thing we want to be able to do is to look at a confidence interval estimating the difference between the two groups. And we're going to start with independent samples. And we want to look at creating that confidence interval used to estimate the difference in the means between the two populations. The conditions here for the central limit theorem still apply. As always, the samples have to be random. They have to be independent, assuming they're not paired. In that case, we have to do something different. And they have to be large enough samples. Generally, they have to be at least 25 or more, or they have to come from a population that is normal, just like it was when we had one sample. Or they have to be large enough to expect at least 25 or more responses. Now, the structure for what this is going to look like, it's analogous to what we did with one sample. We have our estimate, X bar. In this case, it would be the estimate of the difference between the two X bars, plus or minus the T star value times the standard error. And then just note that X1 bar represents the mean for the first sample. X2 bar represents the mean for the second sample. S1, of course, is the standard deviation for this first sample. S2 would be the standard deviation for the second sample. And N1 and N2 are the sample sizes. T star, remember, varies with the degrees of freedom, just like it did when we worked with one sample. Obviously, we are not going to do this by hand. We're going to use StatCrunch, and we're going to focus on doing the interpretation. So I'm going to show you what this looks like in StatCrunch, but these are the interpretations that we want to focus on. And this is going to be really similar to what we did back earlier in the chapter. We just looked at one population using one sample, but we're looking for the difference. We're trying to estimate a difference between mu1 and mu2. So if 0 is in the interval, so remember that would be like if the interval goes from negative to positive, then that means that mu1 and mu2 are probably about the same. There is no significant difference between the two groups because 0 is in the interval. On the other hand, if both values are positive, so like if you have a positive interval, that would be the case where mu1 minus mu2 is positive, and that would represent the difference. Or you could think of it as mu1 is greater than mu2. In general, there's a significant difference and mu1 is probably higher. And then on the other hand, if both values are negative, that would be the case where mu1 minus mu2 is negative. Or you could say mu1 is significantly less than mu2. And that's going to be our estimate for the confidence intervals and the differences in the means. Before I do anything with hypothesis testing, let's go ahead and I'm going to look at the class examples and I'm going to skip down to example 2 here. In your notes, let's go ahead and do this example now, and I'm going to show you how to do this in StatCrunch, and then let's make the interpretation. This is really similar to how we did this with one sample. We're just going to choose 2 sample. That's the main difference. So let me see if I can adjust my window here so we can see this. And we're going to go, well, first of all, let's read the question. The question says, we've got a college randomly surveyed day students and evening students to determine the number of credits students were enrolled in. The data is shown in the table below. So we have 2 different groups here. We have day students and evening students. I'm assuming those are independent. They have nothing to do with each other. It says use the data to find a 95% confidence interval for the difference in mean number of credits for the 2 groups. And then based on your confidence interval, is there a difference in mean number of credits taken by day and evening students? So let's go ahead and look at what this looks like in StatCrunch. I'm going to go to T-Stats, 2 sample this time with summary because I'm putting the numbers in myself. All right, so if you're looking at the table, notice we've got day, we'll call that sample 1, and then evening, we'll call that sample 2. So for the day group, my sample size is 72, the mean is 8.7, and the standard deviation is 3.1. So let's go ahead and put that into StatCrunch. The mean was 8.7. The standard deviation was 3.1 and the size was 72. And so that would be my day group. And then for my evening group, the size is 68, mean is 5.9, and 3.7 I think was my standard deviation, 5.9 for the mean. And even though the groups are different sizes, that doesn't matter. As long as they both meet the criteria of being large enough. So this is, I believe I've got all my data in. Let me make sure I didn't screw something up. 68, 5.9, 3.7, 8.7, 3.1. Okay. All right. Now, they wanted me to do a 95% confidence interval. So I'm going to click down here where it says confidence interval. I'll leave it as 95%. We're estimating the difference between mu1 and mu2. So here is the information. Notice that my lower limit and my upper limit are both positive. So I'm going to write that down. 1.66 and 3.9. I'm just going to say 1.7 and 3.9 are my numbers. So my interval is 1.7 to 3.9. So notice because those are both positive, that indicates that mu1 minus mu2 is going to be positive, or mu1 is going to be greater than mu2. So does this indicate that there is a difference? We're going to say yes. The number of credits taken by the day group, and I'm short on space here, I should say the mean number of credits taken by the day group is significantly larger than the evening group. And larger by how much? Somewhere between 1.7 and 3.9 credit hours. That does give us an estimate of how much we think the difference is. It's somewhere between an average of 1.7 and 3.9 credit hours the day group is taking more than the evening group, and that's what we're expecting here. Now, question 3 says, use the credits data to test the claim that the mean numbers of units taken by the day and the evening groups at the college by the two groups are different, using a 5% significance level. Let's go back for just a brief moment and talk about hypothesis testing. I'm not going to get into these formulas. Again, we're going to use StatCrunch to do the calculations for us. We're going to focus on the interpretation. But just like always, our hypotheses, we're going to have a null and an alternative. In this example, we're looking at not equal to for the alternatives. So my hypothesis, let me go ahead and jot that down here. The null hypothesis, of course, would be that mu1 is equal to mu2. And the alternative would be that it said that they are different. So mu1 does not equal to mu2. So let's take a look at that. So using the same information as the two groups of college students, how many credits they're taking, I'm going back to StatCrunch here. This was my confidence interval information. Don't start over. Remember, if you've already got it in there, just go to Options, Edit, and then we want to click on Hypothesis Testing. Notice that we can adjust the hypotheses, the alternative, according to what we need, greater than, less than. This time we want not equal to, so I'm going to leave it like that and click on Compute. And here is my information. Notice that my p-value is very, very small. It's less than 0.0001. Remember, that's what StatCrunch tells us basically the difference between, or the p-value for the difference between the two groups is 0. So that means we're going to reject the null hypothesis. That means we certainly have evidence that the alternative hypothesis is probably true. So let's go back and make a quick interpretation. It says, does this give us evidence to back up our confidence interval? So we're going to say yes, the p-value was basically 0 according to StatCrunch. And so certainly we're going to say yes, we have evidence that the two support the alternative. So we have evidence that the mean number of credits for the groups are different, which certainly supports the confidence interval that we got. Now, this did say different. We could have said, is mu1 higher than mu2? And so had we done that in StatCrunch, I believe we would have gotten the same information. Let's just check that real quick. If I had switched this to mu1 greater than, because remember mu1 was our daytime group, then same results. We would have gotten the same results. So certainly mu1 is higher. Not only is it different, it's higher. But they said different, so I'm going to go with the alternative that the two means are not equal. And so that certainly does support what we said is the case from the confidence interval. That's really all I want to go over in this video. We will talk about what to do when the groups are dependent. We have to do something slightly different in StatCrunch, but basically the interpretations are going to be the same. So bring your notes with you, and I will see you in class.